Okay, so once we dealt with the design, we go through the implementation. At this stage, it's important that our team understands the source of bugs. It implements or uses static code analysis, which is starting from IDE through doing that on CI/CD or Sonar or any other designated tool for the language we use. We should do code reviews. Of course, this is a manual, but very important thing. And we should be aware that with every dependency we add to our code, we can import a bug. But fortunately, there are tools that do the scan of the libraries dependencies we use against databases, against common vulnerabilities and exposures databases. So to minimize that, we check the dependencies and we keep our libraries and dependencies up to date. And what's also very important, we should log, using, of course, common patterns, because this will allow us to set up alerting and notifications at later stage. Okay, so what is the source of bugs? Well, there are different sources. For example, it can be leaking business logic. Bugs can be imported with third-party libs. It can be because lack of testing, which can be related to deadlines. We can be missing input validation, and of course things like developer mistakes and lack of analysis. So how can we secure the code? Well, code review will also help, of course, and it's not only about security. There is a lot more advantages of using it. For example, sharing knowledge. We should also do the static code analysis at IDE, at continuous integration servers to find potential vulnerabilities. We should scan dependencies. I will show the tool for that later. And we should keep credentials to external systems. Either, those credentials should be either injected at CI/CD and in the runtime environment, or if we want to use to store them in a code, we can take advantage of SOPS project that can be used along with Google Cloud provider, key management system, Azure Vault, AWS Vault, or HashiCorp Vault. I also mentioned that it's important to scan dependencies. In Stepwise, we use Trivy for that. It can scan operating system packages, programming language dependencies. Here, not all the languages are supported, but there are also other tools for specific languages that can take advantages. It can scan container, images, file system, and Git repositories. And there are also some alternatives on the market, like Claire, Anchor, etc. Most of container registry have their own scanners, like Dependabot on GitHub. But we used Trivy because it was very easy and very simple to include it in our pipelines, in our. So once we are done with implementation, we switch to verification. At this stage, we can also do code review of most crucial system areas. At this stage, we should also consider doing fuzz testing, which is testing with random values, simply providing random values to all the inputs or all the in paths of our systems. We should also take advantage of DevSecOps approach, which is Dev, Security, and Operations connections. So all those aspects should be taken in consideration. When we build Docker images, we should either use Alpine or even better distroless distributions or distroless images. Alpine is a very lightweight distro, which has a minimal set of packages. And there is also distroless image. This was introduced by Google. And in Stepwise, we prefer distroless over Alpine because distroless doesn't have package manager or even shell. So even though someone breaches your system, it won't be able to go into your running container. At this stage, we also should take advantage of CI/CD in a way that a lot of verifications and tests should be done on continuous integration server. And what's also important, we should consider, or even better, we should simply do it. Pen testing, penetration tests, and it should be done by a third-party company or a separate team in our company that is specialized in penetration tests. Okay, so the last stage is a release. It of course should be done by CI/CD without any manual work. We should apply at this stage monitoring, for example, Prometheus. We should set up alerting for desired situations, for example, for status codes 401, which is unauthorized. We should set up alerts on specific patterns or regular expressions, and we should monitor our traffic. For example, if our application is supposed to run in Poland, if we see some suspicious IPs from not desired countries or areas, we should also take a look at this. Okay. I mentioned about secret operation before. So this is secrets as a code approach. We can encrypt values of YAML, JSON, ENV, INI, and binary files. It supports external key management systems like AWS KMS, GCP KMS, Azure Key Vault, PGP, and others, and supports key rotation, which is a very important thing to rotate key and not stick to one key all of the time. And at this stage, we also want to take advantage of CI/CD and automation. We should use CVE scanners. We should scan dependencies, scan images. We should do deployment security scans. For example, on Kubernetes, we can install Starboard Operator, which will be running on Kubernetes and will be scanning all the new deployments. We should also do security static code analysis and automate tests for security and run them on CI/CD. I mentioned Starboard Operator. This is the image from their website. You can see that it can do not only vulnerability scan against common vulnerabilities and exposures, but it can do extra stuff like pen test and configuration audit. For example, we may want all our deployments to have resources, limits, and requests defined in our Kubernetes deployment specifications. And you can export reports to HTML, PDF. You can use them with Prometheus, Grafana, or manually through Lens or Octant. Okay, to sum up the presentation, we should be thinking about security at early stage, and the training, security training, should be important aspect of that. We should identify sensitive data at design stage. We should do code reviews, static code analysis on IDE, on continuous integration, wherever possible. We should scan and update dependencies also on CI/CD, and notify developers if dependencies are either vulnerable or out of date. We should scan Docker images on CI/CD, on image registry itself, for example, on Harbor, or I don't know, on Google Container Repository. Most of the registries already have scanners built in, and also scan running containers, for example, by using Starboard Operator. I would recommend also preferring distroless images over Alpine. We should do penetration testing of our system. We should also use web application firewalls wherever it makes sense. And we should implement monitoring or set up monitoring of our application. Thank you for watching. I hope you found the stuff interesting. If you needed to contact us, you can reach us at contact@stepwise.pl. Thank you.